Good morning, good afternoon, good evening. This is Mr. Payne bringing you graphing quadratics. The first thing we would like to start off by talking about are the three ways that you may see a quadratic written. These three ways each will have its own benefit, and the one guarantee that I can give you is that no matter how it is written, it can go into your calculator, which is a great thing. The first way is the standard form. The standard form example will be written on the first line as ax squared plus bx plus c. Now I know that may be tricky because there's all letters there, but I'm going to help you specify that right now. The example that I want to give you is going to be x squared minus 7x plus 12. The benefit of the standard form is that you can tell quickly what your A, B, and C are, which will be very helpful when we get back from Thanksgiving. In this case, my A is 1, my B is negative 7, and my C is positive 12. The second form I would like to talk about is the vertex form. And once again, I'm going to give you the letter version so that we can talk about it and explain what this form is all about. A times x minus h to the second power plus k. So what that means is, and for an example I'm going to give you, it's going to be negative 2 times x minus 5 squared plus 3. Now a few things in each formula can be a little different. This a up front here can be different, this sign inside can be different, and the sign outside could be different. So every example is going to be different, and for every example that is different, the vertex, because it's called the vertex form, will be different. So I'm going to go ahead and give you some of the benefits. One of the benefits is looking at this quadratic in this form, you can quickly identify the vertex, the axis of symmetry, which way the parabola will open, and if it's going to be skinnier or fatter than the parent function x squared. So let's go through this problem and break it down. The first thing I would like you to write down is that my vertex is going to be a positive 5, positive 3. Now hopefully that you see where I got these numbers from. Well, I got the 5 from inside my parentheses, but you may say, well, Mr. Payne, that's a negative 5. What we want to remember is that whenever it's inside my parentheses, we're going to write down the opposite. So if I see negative 5, we're going to write down positive 5. Anything that's outside the parentheses will always stay the same, so we're going to write down 3. So my vertex, notice that it's written as a point, because it's also known, my vertex is also known as my turning point, is 5, 3. My axis of symmetry, and I know all these words are new to you, but we're going to learn them on the fly. My axis of symmetry is x equals 5. Once again, hopefully that you can see that this 5 is the same as that 5. Oh, and look at what it says, x equals. So therefore, my axis of symmetry, and how I remember that, is what letter is in the word axis. I hope you can tell me that it's x. My x is my x value of my vertex. Now you may ask, Mr. Payne, how can I tell which way is it going to open? Well, this sign right here is going to tell me which way it's going to open. The negative means that it's going to open downward. So it's going to, the parabola, or the U shape, is going to be flipped upside down because the A is negative. The last part of your notes from the vertex form is talking about the A again. Well, this a out here is going to tell me, we know that it's what number? The a equals 2. So this parabola will get skinnier. And you may ask, what am I talking about? Because you haven't seen any pictures. Well, let me draw you a quick little diagram here to explain quickly what we're talking about. So here is my axis, x and y axes. I'm going to draw you my parent function. My parent function, in this case, it's going to be upside down, right? Because you told me, it's close enough to my parent function. Well, we have a great example. Let's think about that too. My parent function is my 1, and we call it my parent function because it's the first one written down. Okay? My 2 will tell my new function that it's going to be skinnier. And how am I going to remember that? And I'll do that in a different color. It's going to be a tad skinnier. It's going to still have the same vertex. It's just going to be skinnier. And as this number right here, as this number gets bigger, the parabola will get skinnier. Now, what do you think happens here? If this was a fraction, what do you think would happen to this parabola? It would get a little fatter. Now, let's talk about if I were on a treadmill. If I ran for 2 hours a day, I naturally would get skinnier. If I ran for a half an hour each day, and I didn't really exercise that much at all, as the less I exercise, the fatter I'll get. So you want to remember that and think of that as exercising. As the larger this number gets, the skinnier my parabola. The smaller that number gets, the fatter my parabola. Hopefully that little analogy will help you remember which way that parabola is growing compared to its parent function. Remember, parent function means the first parabola that was drawn. The last form is called the factor form. And the example that I want to give you is going to be x plus 7 and x minus 3. The benefit is that you can quickly identify your roots. So in this case, my roots are x equals -7 and x equals a positive 3. Once again, hopefully that you can notice that, inside my parenthesis says positive 7, so when I write it down, it is -7. And inside my parenthesis is -3, when I bring it out, it is a positive 3. Just like when we were working in the vertex form, anything that's inside my parentheses and we bring it out, because we're going to teach you eventually how to solve for that, is going to be the opposite. Now we're going to move on to the quadratic table. The table is super important. The first thing that you want to identify when you're talking about your table and you're looking at your calculator for a table, or if you're looking at a question to determine if this is a quadratic, you want to look for the pattern right here. You see how this 0 and that 0 match up, and this 8 and that 8 match up? The only guy that doesn't have a pair is this guy right here. We call that guy our turning point. If I'm making any notes on my graph or on my table and making some notes, I would like you to make the same notes so that we have the same language and the same vocabulary written down. My turning point is just another way of saying vertex. So we identify my vertex immediately by looking for my pattern. Every quadratic will have that pattern. It is our job to go into our calculator or onto that picture and find that pattern. So let's write down, what is my vertex? My vertex, and we write it as a point, don't forget, is 3, -6. My axis of symmetry, don't forget from the previous slide that my axis of symmetry has the letter x in it, so I'm looking for the x value of my vertex, which is going to be giving me 3. Now, we're going to identify my roots. And some other words that you may hear about when we talk about roots are going to be solutions, or x-intercepts. Or zeros. All those four words mean the same thing. So in this case, how am I going to find my x-intercepts? Well, no fear, we're going to look no more. It's wherever my y value equals 0. So in this case, my roots are going to be x equals -3 and x equals 4. We can say that this quadratic has two solutions because there are two roots. You may also hear, and they may ask you for, the positive root. Well, if they ask you for the positive root, you would give them the +4. If they asked for the negative root, you would give them the -3. Those are also some other ways that you may hear that being asked. The last slide is all about the quadratic of graphing. Another word for quadratic that we see right here for the first time is parabola. It just means that it is a U-shaped graph. Once again, we see the word x-intercepts. We also know that those could be my roots or my solutions or my zeros. We see the word vertex. The vertex is right down here. It's my turning point of a graph. In this case, my y-intercept is also my vertex. You know that your y-intercept is where the function hits your y-axis. Let's look down here. Once again, we find our vertex, our x-intercepts, and now in this case, our y-intercept is different. The new things that I want to share with you in this graph are talking about the minimum point and my maximum point. And you can read this slide by yourself when I get done. But basically it's telling you that when my vertex is at the top, that's called a maximum, and when my vertex is at the bottom, it is called a minimum. Right here in both notes, it is talking about that positive A and that negative A, like we mentioned on the slides earlier above. At this point, the last sheet of your packet, is the key vocabulary learned from this video. If you need to, go back, rewatch the video so that you can fill in all these vocabulary words. Thank you and have a great evening.